Hello everyone, I am Christine Garay from PSCS 3BGB. In this demonstration, I'll be showing the rules of communication using Cisco Packet Tracer. So as you can see, I use a star topology where each piece is connected to a central switch. So we have two local networks connected by a router, allowing devices from one to LAN to communicate with another. So we'll use this setup to explain how communication happens through the five protocol rules: the message encoding, message formatting and encapsulation, message size, message timing, and message delivery options. Let's start with message encoding. Watch as I send a message from PC1 to PC3. When I click Simple PDU and select the two devices, a small envelope icon appears. This represents the data being sent. Switch to simulation mode and click Play. As you can see, the packet travels from PC1 to the switch, then to the router, and finally reaches PC3. This shows how the message is converted into binary bits and electric signals, which are transmitted from one device to another. Next, let's move to message formatting and encapsulation. Click one of the packets and open the PDU information. So you'll notice that the message passes through several OSI layers: the application, transport, network, and data link. So each layer adds its own header information. For example, the transport layer adds the port number, the network layer adds IP addresses, and the data link layer adds MAC addresses. So this entire process is called encapsulation, and it ensures that data can be properly delivered and understood at the destination. Now let's discuss message size. Every network has a limit on how a big single message can be. This limit is called the maximum transmission unit, or MTU. If a message exceeds this limit, it gets divided into smaller packets automatically. To demonstrate this, I'll send a larger file or message from PC2 to PC3. So as you can see, in simulation mode, multiple packets are sent instead of one big one. This helps prevent congestion and ensures smooth communication across the network. Next, let's move to message timing. So timing refers to when messages are sent, how fast they travel, and how long it takes for a reply to come back. As you watch in simulation mode, the packets move one by one, not all at once. If the network becomes busy or if one device responds slowly, timing delays may occur. These timing rules help keep communication synchronized, preventing devices from sending too much data too quickly. For message delivery options, there are three main types: unicast, broadcast, and multicast. The unicast, the message or data is sent to one specific device. For example, when a ping from PC0 to PC3, that's unicast because it targets only that device. Broadcast, the message is sent to all devices when the same network. A common example is an ARP request. When it's sent, every device in the network can see the packet. Multicast, used in more advanced scenarios like video streaming. So here, the data is sent only to selected devices that need it, not to everyone.